Last class I have covered foundations. Basically classification, it is two types. If I divide into two types, shallow and deep. Shallow again footing and raft. Footing is isolated, combined and strip footing. Raft, conventional raft and buoyancy raft. Deep foundation, if I classify into two parts, one is your pile foundations. This pile foundation may be a pile raft, friction pile, end bearing pile, that will be depending upon how it transfer load to the ground surface. Caisson or well foundation, generally they have been provided in bridge or railway bridge. Then of course there are machine foundations to required to install machines over a foundations. Then retaining structures. In retaining structures there are four categories: conventional gravity retaining wall, RW is your retaining wall, cantilever retaining wall, counterfort retaining wall, RE wall, reinforced earth wall. This I have covered with your foundations, started with this. Then start with your isolated footing. Isolated footings. Isolated footings, if you look at here, suppose this is a plan of a building, there are separate columns here as well as here. Then if I can take it, isolated means it is a single footing without interference. So, where this isolated footing has been utilized or may be adopted to support column load of a building, then it is independent of each other, independent of each other without influence of other footings. If I say isolated footings, generally these are all independent footings. If this is the plan of a building, if I say this is isolated footing, this is one isolated footing, generally it supports how your load transfer from superstructure to beam, beam to column, column to foundations. Generally it supports your individual column loads. At the same time it is independent, neither this or this footing are going to influence each other. So, in that case it is isolated footing. Then come back to combined footing. Combined footing, look at the plan, one of the plan here, look at the plan here, and there is a footing here, there is a footing here, and it has been combined. So, it has been designed to support two or more column loads, and isolated footing, that means why there is a combined footing? When there is a overlapping, there is a overlap of two isolated footings. If these two footings here, they are very close to each other, suppose they are overlap, that means pressure intensity or pressure bulb is overlapping each other, in that case you can combine the two footings and prepare a one footing. In that case this is called combined footings. Then third one is your strip footing. Strip footing, if I draw it strip footing, this is my ground surface, and load bearing wall. Strip footing is a it support load bearing wall, and from long to narrow continuous foundations, if I draw a strip footing in 3D view, how it looks. Here it is a wall, this wall has been supported, and this wall, here there is a wall, here there is a wall, here there is a wall, in that case it is called strip footing. So, particularly in shallow, first part is your footing, and footing it is three parts: isolated footing, classified into three parts: isolated footing, combined footing and strip footing. Now come to next, raft or mat foundations. Raft or mat foundation means, that means large number of columns is founded on one single slab. When individual column footing are together found to be occupied individual column footings are together and it occupy more than 70% of plan area, then in that case you can go for raft foundations. If you look at here, there is a plan of this building, then there is a column here, 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 column load here, column is here, column here, column here, this is here and this is here. So, in that case there are many columns are there and there will be overlapping with each other, first condition. Second condition is it is occupying 70% of your plan area. If you independently if you do it, it is occupying 70% of your plan area. In that case what has been done, a single slab, that means this will be made a single slab. With a single slab, these are not the walls like previous, these are all your columns, that means a single slab has been made, over this columns have been erected. So, in that case it is called raft as well as mat foundations. Now, go to the next, that is your, there are in raft and mat foundation there are two types. If I say raft, as I said earlier, this is your conventional, and second one is your buoyancy raft, conventional and buoyancy raft. If I go for your conventional here, and here is your buoyancy raft, conventional raft and buoyancy raft. If you look at here, let me draw the figure first. Ground surface, and there is a single slab, these are all your columns, this is your column, this is your plinth level, or here it is backfill, and in this case this is your plinth fill. In conventional raft, it provided at shallow depth, and backfilling is done. Backfilling is done to reach ground surface. Then plinth filling is also done. Plinth filling also done, so that you can start the floors. So, conventional raft, there is a single slab with these columns are there, and backfilling has been made so that you can reach up to the ground level. Then plinth filling has been made so that ground floor, first floor, second floor, it will continue like this. This is your conventional raft. Now, come to your buoyancy raft. If I draw it a buoyancy raft, then there is a slab here, single slab, draw a column here, draw a column here, it is column, one column load, here one more column load here, then you make it here, that is your ground floor, and this is particularly void, this is your void. If I can write it, placed same depth below ground surface, then ground floor slab is provided, that means slab is provided at desired height. The difference between your conventional raft and buoyancy raft, in conventional raft there is a backfilling, you make the backfilling so that you can reach up to your ground surface, but in buoyancy raft, place same depth below your ground surface, and this there is no filling, there is a void, that is why this is called buoyancy raft. More detail I will discuss as the class progress. This is a basic introduction to your foundations, different types of foundations. Now there are deep foundation, one is your pile foundation, other is your pier or caisson foundation. pier or caisson foundations. In pile foundations what will happen? Pile foundation what will happen? When this bearing capacity of the soil is not adequate to support your structures at shallow depth, that means this is the case where you are not getting the bearing capacity of the column load, that means what you are planning for a foundation. At shallow depth bearing capacity of the soil is not adequate, that means you are getting safe bearing capacity of the soil at deeper depth, then in that case you can go by means of your pile foundations. Pile foundations are generally provided by means of groups or with piled raft or without raft or with a cap. So, that means if it is connected piles with a cap monolithically, we can say it is a piled raft. This particularly load transfer from column to raft, then raft to pile, and from pile to soil. Depending upon the soil conditions, depending upon your soil condition, it may be a friction pile. That means if it is a friction pile, what does it mean? By means of group actions, by means of side frictions, entire load will be transferred. If it is only end bearing, by means of end bearing resistance, it resists the load coming from your superstructure. If I say both end bearing and both frictional piles, that means part of the load has been taken by means of side frictions, part of the load coming from columns from the superstructure has been taken by your end bearing. So, this is case of your pile foundations. Then piers and caissons, particularly it is used to support heavy structural load, like from bridge or maybe railway bridge. So, basically if I draw a pier or caisson foundations, it is a large diameter piers are there, here it is large diameter piers are there. Then slab has been made and deck has been made to support your structure. Generally the diameter of the piles as per Bureau of Indian Standards, it is minimum should be 400 mm, 350 to 400 mm, 35 centimeter or 40 centimeter, but here it is varying more than a 1 meter. Large caissons, particularly where there is a, and this piers and caissons provided along the rivers, flow of the water is there and you penetrate these caissons or piers inside your river bed. This is my river bed and HFL ice flood level where it goes water up to this river bed. Below river bed you penetrate and it is a large structure, very vast structures. So, it will go up to deep strata of your soil, here it is also a deep strata of your soils. So, there are also pile foundation, as I said, different types of the pile foundations, frictions, end bearing and both end bearing and frictions, as well as pile foundation with a cap or piled raft connected with the pile. Sometimes you want to provide a raft at the, generally raft has been provided at shallow depth, sometimes it is not supporting, your settlement and bearing capacity are not coming within your permissible limit, then raft with connected with a pile of small L by D length, embedment length, it satisfies your criteria. This is what your pile foundations. Piers and caissons, particularly bridge, railway bridge, highways, bridge, where these big piers are there, and it has been basically provided where near the rivers. If there is a river and at the two sides I can say these are my piers, abutments and in between I can say these are my piers, and at the shore it has been called abutments. So, this is all about slight description of your classifications. Foundations, two types, shallow and deep, and shallow is your again two types, footings and rafts. Footings has been classified isolated, combined and strip. Raft classified conventional raft and buoyancy raft. Deep foundation basically classified into two, pile foundation and caisson foundations. Now come to your isolated footing, it is basically to support column loads. At the same time two isolated footings should not overlap, and combined footing, when there is a less space, two column loads are there and you want to provide support in that space, two column loads, and overlapping is there. So, you combined it, in that case it is combined footing. Then strip footing, particularly the strip footing to support load bearing wall. This is your footing, this is your wall coming out, this is most common in residential buildings. Then raft or mat foundations, what will happen if you remember here, as I discussed here, combined footing, two isolated footing. So, in this case of your raft and mat foundations, if you look at here, the area is predefined, this is the available area for your constructions. So, in that case multiple column loads are coming, you cannot provide isolated footing because there is a overlap. At the same time it occupies more than 70% of your plan area. That means if I provide a isolated footing here, isolated footing here, isolated footing here, isolated here, it occupies more than 70% of your plan area. In that case take it as a single slab, this is a single slab and this is a complete single slab, and with this slab this column has to be connected monolithically, and this is called raft or mat foundation. Generally it has been provided at shallow depth. Raft and mat foundation has been classified into two types, one is your conventional raft, other is your buoyancy raft. In conventional raft there is a single slab and it has been provided at shallow depth. Generally backfilling has been done to reach your ground level, then plinth filling is there so that your flooring has been started. But in this case buoyancy raft there is no backfilling, you can start your plinth level, ground floor as per your choice. So, there is a void here. So, this is the difference between conventional as well as buoyancy raft. Then come to your pile foundations, pier or caisson foundation, that means your deep foundations. Pile foundations, when at shallow surface bearing capacity of soil is not good enough to support your structures, to support your structure load coming from structure to beam, beam to column, column to foundation, in that case you can go for a pile foundations. Generally diameter, pile diameter is 350, 300 to 400 mm minimum diameter. So, you can provide pile as a single as well as groups. Generally for foundations group is preferred. Sometimes pile can be provided with a pile cap, sometimes pile can be provided with pile draft. That means cap and pile has been connected monolithically, and the load transfer mechanism of your pile foundation is it transfer load to your ground surface or to your soil by means of frictions, side frictions, by means of end bearing or end resistance, or by means of both friction as well as some part of your frictional resistance, some part of your end bearings. Piers and caissons, generally it provides to support your heavy structures, particularly in bridge or railway bridge, where river is passing, there is a water current is there and large diameter piers penetrate below your river bed. So, this is all about your classification of your deep foundations. Now, come to your design criteria. As an geotechnical engineer, in design criteria, so there are two design criteria. One is your adequate factor of safety against bearing capacity failure, then settlement within your permissible limit. Settlement means both consolidations as well as immediate settlement as well as your differential settlement within your permissible limit. So, two design criteria, one is your bearing capacity failure, adequate factor of safety generally 2.5 to 3 has been taken. Second part is your settlement, it should not be excess settlement. So, it should be within your permissible limit. So, as per IS code you can download it IS 1904 1986, it is there. It is about your permissible settlement. Permissible settlement. If I put it in this way, I put it isolated footing, then two part is your second part is your raft. In isolated footing, one is your sand or hard clay, second part is your plastic clay. Raft again sand or hard clay, second part is your plastic clay. Plastic clay, then steel structure, in steel structure rho maximum is your maximum permissible settlement, then rho by L is your differential settlement 50, these are all in mm, 50, here it is 50, here it is 75, here it is 100, then here it is your 1 by 300, 1 by 300, 1 by 300, then 1 by 300. This is all about our steel structures. Now, RCC structures, I write it RCC reinforced column, RCC structures, then rho maximum and rho by L, this is a 50, 75, 75, 100, and this will be a 1 by 666, then 1 by 666, and this is your 1 by 500, and this is your 1 by 500. Then multi-story building, last one is your multi-story building. multi-story building, this is your rho maximum, this is your rho by L, here it is 60, 75, 75, 125, here it is your 1 by 500, 1 by 500, 1 is to 400, and here it is your 1 is to 300. Why I wrote it? I could have said you can collect it Bureau of Indian Standard provisions. Some colleges it is not possible to get it, that is why I write it so that you can note it down. So, differential settlement is in the ratio, but the maximum permissible settlement, these are 50, 50, 75, 100, 50, 75, 75, 100, 60, 75, 75, 125, these are all MMs. So, this is what Bureau of Indian Standard has been proposed, particularly 3 cases, one is your steel structure, second is your RCC, last one is your multi-story buildings. So, this is all about your classification of foundations, design criteria, and what is the provision for your settlement, Bureau of Indian Standard. This is an introduction. Next class I will start your shallow foundation along with your bearing capacity, main topic I will start it. Thank you.